every year I have Math 1 kids that try to do these rules with the coefficients. They're not called coefficient properties, they are exponent properties. So they're rules that only deal with the exponents. They're going to help us operate with exponents. So when I say the word operate, what do y'all think of?
Worksheet.
Okay, addition, subtraction. I heard somebody say operation, multiplication, division, that kind of stuff, right? Okay. All right, y'all ready to write down our rules? Virtual kids, y'all ready?
Yes.
All right, so I'm gonna ask y'all how y'all would rather have it set up. There are 6 rules. Would you rather me do all the notes first and then do examples, or do you want to do each rule with an example?
Each rule with an example.
Okay, that's what they said too. Okay. All right. All right, so rule number 1. Rule number 1 is for multiplying powers. Does anybody know what the word power means? It's a synonym for something. What's a power?
Is it synonym for exponent?
Good, it's a synonym for exponent. Good job. So it just means exponent. So we're talking about multiplying things with exponents, okay? So this is your rule you're gonna write. So when multiplying terms with like bases, does anybody remember from middle school what we do with the exponents? You don't multiply them.
You add them.
Oh, good. You do combine them. You add them. Very good. Extra credit, girls. So my next question while you're writing still, so don't quit writing, just listen. Did they show you why you add the exponents?
Yeah.
Okay, you've always wondered why. So some people are saying yes, others are saying no. So I'm gonna show you why you add the exponents so you can know where it comes from, okay? Because y'all know I'm big on that. I like you know where stuff comes from. So let's see, who do I wanna talk to? Jordan, give me a number.
6.
And then Ashley, give me a number.
5.
Okay? So you don't have to write this one unless you want to. It's up to you. What does x to the 6th mean?
Multiply 6 times.
Good. Multiplying x 6 times. So do y'all agree this means I have 6 x's like this?
Mm-hmm.
Huh? Okay. What does x to the 5th mean?
5 x's.
So I've got 1, 2, 3, 4, 5 x's. When you are multiplying two things, do y'all agree we're just putting them together?
Yeah.
Okay, so how many x's do I have here?
11.
So you are just adding the exponents. Does anybody remember what this is called from middle school, where you write it all out?
Standard form.
Good, good. Racking up them points for a new unit. Look at my girls. My boys got to catch up. That's expanded form. Now, listen to me carefully. In Math 1, Do you think the exponents are going to be easy like 6 and 5?
No.
No, I'm about to give you one that has an exponent of a 20 in it, okay? So we are not going to expand in Math 1, but I did this so you could see why we add the exponents. If you expand them out, there's 11 of them there. So when you're multiplying, you add the exponents. Are we okay with that?
Yeah.
All right, let's do 2 examples, then we're going to move on to the next rule. Can you see it? That is a 12.
Wait, what you need the X for? Why
What
can't
you
you
mean?
just put like 2 and then 12?
No, it's negative 2x to the 12th. So this means I have 12 x's.
Oh.
X is your base. That's your variable. Just like up here, we had x to the 6th, x to the 5th. Yes, so good. What they just said in class, they were like, okay, this one has coefficients. Let me ask y'all a question, and I'm not trying to be some type of way. Y'all know how I am. Did I write coefficient properties?
No.
No, do not do this. Watch, don't write it. Do not do this. That is not 5. You do not add the coefficients. What do I do with those 2 numbers? What do you think?
Nothing.
Yes, just multiply them. They're 2 numbers. So you're going to multiply the actual numbers. You cannot multiply exponents because exponents aren't numbers. They're powers. So watch, we multiply our numbers. So what's negative 2 times 7? Negative 14. But now what do I do with my exponents? What does my rule say I do? Add them. So what is 12 plus 8? 20. So this would be negative 14x to the 20th. That's your answer. Easy or hard? What do we think? Easy. Okay, do not multiply those exponents. Add them. You just got to know exactly what to do. Yep. Amen. All right, let's do another one. Don't multiply the numbers out front. Those are not don't multiply the exponents. You confused me because she said something else. Don't multiply the exponents you add. Because if you expand them out, put them together, they're combining, they're adding. The numbers out front, you do multiply because they are not exponents. That is literally saying negative 2 times 7. Let's step it up a notch. I feel like that was a little easy for y'all. Let's do a parenthesis. Don't say that. So, you got it, girl. Don't do that. Don't be, what's a good word? Unconfident. Unconfident ain't a word. This is why I teach math. Don't second guess. You got it. All right. That says 15, baby. Y'all always playing my handwriting. I got good handwriting. All right. Does everybody agree we are multiplying these 2 things? That's what the parentheses mean, right?
Yeah.
So do you see how I gave you a different representation? You could see the multiplication dot or you could see parentheses. But either way, it means we're multiplying. So let me ask y'all a question. What do we do with our numbers out front? Yeah, what do we do with our coefficients? You multiply them. If it's telling you to do 8 times -1/2, that is what you do. Now, please do not go grab a calculator. What is half of 8? Good. So what kind of 4 should this be? -4. There we go. He's excited. Good job, Krishan. -4. And who do I want to talk to? Who's somebody good to talk to for some extra credit? Who wants to talk? Ashley, I'm going to talk to you. Usually you are more vocal than this. She's like, okay. All right, Ashley, what do I do with my exponents?
You add them.
Good. If you are multiplying, you're going to add the exponents. So guys, find your like terms. Did you guys see in the rule? I said with like bases. Does everybody see this?
Yes.
If the bases are not the same letter, you can't go add them together, right? I feel like we know that. So go look at your bases. X goes with X. What is 15 plus 4?
19.
There we go. Y goes with Y. We got to be careful on this one. I gave y'all a tricky one. We know this is 20 Y's, right? How many Y's is this back here?
1.
Oh, good. That's 1 Y. So how many Y's do I have now?
21.
21. Very good, y'all. Y'all feel like y'all could do multiplication ones?
Yeah.
Okay. Y'all seem okay with them. So if y'all are good, I'm going to move on to rule number 2. Rule number 2. Better not be making fun of me. I'll throw a pin at you. Yep. Do y'all have this copied?
Yeah.
Okay, I'm gonna flip. There are 5 rules. And then I'm gonna put some combo problems for us to try, okay? All right, rule number 2. How did I format it? All right. We're gonna talk about dividing powers. All right, I feel like quizzing y'all and making y'all think today, so listen up. When we multiplied, do you guys agree multiplication and division are opposites?
Yeah.
Okay, so when we multiplied, we added the exponents, right?
Mm-hmm.
So now if we're doing the opposite by dividing, what you think we're gonna do with the exponents? Subtract them. Good, 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 good. All right, so here's your rule for dividing. When dividing terms with like bases, you're going to look where the bigger exponents are. This one's a little bit different. So just write that down. We're going to look where the bigger exponents are. And we're going to subtract them, but make sure you do the bigger one minus the smaller one. We'll talk about why we have to do that when we get to rule number 4. You want me to read it to you? Look where the bigger exponents are. Let me know when you're ready for the next part. And subtract the bigger minus smaller. All right, y'all know I got to show you where it comes from, so you're not thinking I'm making crap up, because this is like actually proven, okay? You ready? Let's see, who I want to talk to? Marissa, give me a number, girl.
8.
Alex, give me a number. There he goes. Alex. Oh, he put it in the chat. Let's see what we got. 5, perfect. All right, check it out. Again, you don't have to write this one. You can if you want to, okay? If we expand this, just like we did last time, how many X's would I have in the numerator in the top?
5.
5. How many X's would I have in the denominator or the bottom?
8.
Good. 2, 3, 4, 5, 6. I'm gonna run out of room. There's my 8th one right there. Okay. We did learn this in middle school. I know we did. Not the expanded form, but just watch this. What is X divided by X? What happens?
It cancels.
It cancels. X divided by X cancels. X divided by X cancels. Cancels, cancels. How many are you left with?
3.
3, and where are they at? Ugh,
1.
I hate the word bottom. What's the math word? There we go. Denominator. So if you have 5 markers, here's 4. If you got 5 markers and you split them into 5 groups, there's 1 in each group, right? So remember, if it's an understood 1 in math, we don't have to write it. So it's like canceling. Anything divided by itself cancels out. So good. So what he said, y'all said there's 3 left in the bottom. Where were there more to start with?
To the bottom.
In the bottom. That's why they're left in the bottom. So if you do 8 minus 5, do y'all agree we get 3? But they go where there were more. Does everybody understand that?
Yeah.
So you would write this, there's nothing left in the top. It's an understood 1. And then you have 3 X's left in the bottom. That's how you would write that. So it's like a fraction because the top cancels out. So do we feel like we can try a couple examples again?
Yeah.
Uh-huh. Okay, let's do it. We'll leave that so y'all can see it still. 1 over X cubed. So if there were actual numbers, like I'm about to give you, it's okay. You're just reading my mind. So you're saying like this. I picked 8 again. Whoever picked 8, we picked the same thing. All right, so there's your first example for dividing. All right. Does the rule say that we subtract the coefficients?
No.
No, it's an exponent rule. So what do you think we do with these coefficients right here? What's it telling us to do with those 2 numbers?
Divide it.
Divide them. Now, let me ask y'all a question. Can we do 4 markers and split them into 8 groups? You can take 4 markers and put them into 8 groups.
No.
No. So if we can't divide them, can we at least simplify them? Can we simplify 4 over 8?
Yeah.
Yep.
Okay, what does it simplify to?
1/2.
Good. I like what he said. He said -1/2. That's good. So -1 over 2, because 4 goes into both of these. So if you divide them both by 4, that would be 1 over 2. Good. Where are my A's bigger?
At the top.
I knew y'all were going to say top. What's the word? Numerator. Good. I want to make sure you know what a numerator is. They're bigger in the numerator, right? So they're going to end up in the numerator still. Wherever there were more, that's where they will stay. Now, what do I do with my exponents? Subtract them. Good. So what's 8 minus 2?
6.
There will be 6 left. Now, let me show you. You put 8. Let me show you another way you could see this.
How you getting out -1?
We simplified 4 over 8, Jordan. Do you agree if we got 4 out of 8, that's the same as a half?
Yeah.
And then it's negative. Good question. What were you going to say? No, it's either whatever you're left with. If it started with a division bar, there's going to be a division bar to end with. Does that make sense? Now, do we have to have the 1 here?
No.
I don't. Yeah, I'm asking you, do we have to have it? I'm hearing yeses and nos.
No.
All right, let me give y'all an example. That's why I always got my whiteboard ready. Do these mean the same thing?
Yes.
Doesn't matter if the 1's there.
No.
No.
No, so you don't have to put the 1. So you could also see this as negative a to the 6th over 2. I will take it either way. Delta math will take it either way because they mean the same thing. Does that make sense? All right, let's do another one.
Yes.
8 minus 2, baby. Kamari, you good? Let's do. Y'all doing so good. We're like halfway done because the last 3 rules are faster. These are the 2 basic ones. All right, what do we do first? So y'all are saying the same thing in class and online. They're saying divide, and in class they said take care of your coefficients out front. So what is 14 divided by 2?
7.
7, and it's a whole 7, right?
Mm-hmm.
Y'all love to say it's a whole this, it's a whole that. Y'all used to. One kid came in late. He said, I got a whole pass. I was like, well, I sure hope so. So if it's whole, it goes in the numerator. Because that would be an understood 7 over 1, right?
Mm-hmm.
Y'all remember that from last unit? Okay. So that is 7. Now, talk to me. I'm flipping papers up here. What do I do with these guys? Ooh, add.
Subtract them.
Subtract them. Good. So you said add first. So W to the 3rd and W to the 2nd. Which one's bigger?
The one on the numerator.
Good. Look at that vocab. The one in the numerator. So the W's will stay in the numerator because that's where we have more. So what is 3 minus 2?
1.
1. Good. Where are my Y's bigger? Cam, I hope you looking back.
In the denominator.
In the denominator. So they're going to stay there. I sure can. Sorry, baby. They're W's. All right. So in the denominator, what is 4 take away? What is this one in the numerator?
1.
Good. So y'all, what is 4 take away 1?
-3.
3? Now, do you have to put the 1 with this W?
No.
We just talked about that. So you could also see it 7W over Y to the 3rd. Please don't say Y3. Say Y cubed or Y to the 3rd, okay? Do y'all feel like you can do the dividing problems on your homework?
Yeah.
Yeah? All right. Kershawn, you still think it's easy? All right. Anybody have any questions before we move on to rule 3?
No.
Y'all are good?
Yeah.
I told you it's kind of a lot of notes today, but tomorrow we're just going to practice and play a game. All right, rule number 3. All right, raising powers to a power. What does this make you think of? What do you think? If I say raising one power to another power. Okay. What if we're not done with our exponents yet? We added exponents, we subtracted exponents. Good, we haven't multiplied yet. So when you raise a power to a power, you do end up multiplying, okay? Let me show you what I mean by power to a power though, and you don't need to write this. I just want to show you because we'll write something in a second. But what if I have like x cubed and then I want to take that x cubed and I also want to square it? This is a power raised to another power. Now I want y'all to think back to PEMDAS. Anytime you see parentheses with something on the outside, what do you do with it?
Distribute.
Yes, that's the word I was looking for. Good job, extra credit. You distribute. So that's what we're going to do here, okay? So raising powers to a power. Here's your rule you need to write down. I'm going to put the word whole. I got to be hip like y'all. When taking a whole term and raising it to another exponent, you distribute, which you guys said means multiply, so I'm going to put multiply in parentheses. Into everything on the inside. I'll read it to you, babe. Of the parentheses. This rule is long, but when we actually do the examples, y'all usually like this one. So which part you got, sweetie? I'll read it to you. Are you done here? What part you got? I'll read it to you. Okay, to another exponent, comma. You distribute, which means multiply. So you put multiply in parentheses. The exponent in to everything inside the parentheses. This is like the most notes we'll have to take all unit. So y'all just hang with me. But if we get them all done today, like I said, y'all just be practicing tomorrow. You good, babe? All right.
How many rules is it?
Jordan, we done already covered this. You joined late. 5. Jordan loves me. Right, Jordan?
Not when you get all these notes.
Okay, sassy. I hope you're going to be in person next week. You're going to come, right?
Yeah.
Okay, cool. I didn't know if you were
I thought it was
selecting.
only 4 rules.
Huh?
I thought you said only 4 rules.
No, there's 5 rules. I said 5, right? Okay, yeah, 5 rules. I might have said something else was 4. All right, let me show you where this comes from. Y'all know I got to show you where it comes from. So I'm going to use the example I just gave you. Again, you can write this or you can just watch. Is everybody ready? Cam, you watching? Okay, if I square this, if I am squaring what is inside, what does that mean I am doing? Multiplying it by itself twice, right? So what this means is x cubed times x cubed. Well, we just learned that when you are multiplying, what do you do with your exponents?
Add.
Yeah, so what's 3 plus 3?
6.
So if you look at the top where we started, if you just did 3 times 2, wouldn't you get 6?
Yeah.
So my kids like this rule because usually it's a shortcut. It helps you out, all right? So you're just going to distribute that exponent in. So let's do a couple examples. I got 2 if y'all are okay with 2 again. Zoom out a little bit. I didn't realize we were that zoomed in. All right, example 5. Actually, can I just skip to one that has 2 variables, a little bit more challenging? Can we just do one example? Y'all let me know. If you need another one after this, we'll make up another one. You need 2? Are you just saying that to be needy, or you actually need 2? Just to be careful. Oh, I like that. Okay. We can do a second one. I might have y'all try one so I can shut up for a minute or 2. My mask's getting hot. You need me to read it? Okay. You were looking at me. Jordan talking about something I don't like you when you give us all these notes. LOL. Hey, Kamari. Other Kamari. Hey. Graham Cracker. He's ignoring us. He probably went and made him some noodles like the other day.
Now you know I ain't gonna answer to that.
Graham Cracker. All right. We've got stuff on the inside being raised to the 5th power. Does everybody see that?
Yeah.
So what does your rule tell you to do with this 5th power, this 5 as the exponent? What do we do with it?
Distribute to other.
Distribute it to everything. So I need y'all to watch this. Y'all are usually fine taking it to the 4. Y'all are usually fine taking it to the 2. What do you think people forget about?
Coefficient.
Good, the coefficient. You got to also take it there. Does everybody see that?
Mm-hmm.
Now, I need you to listen. We said you multiply, but that is for exponents, because remember, these are exponent rules. So listen to me carefully. We are not doing 2 times 5. 2 is not an exponent. What do you think we are doing here? What will this literally say? 2 to the what?
5.
Good. 2 raised to the 5th. It's not 2 times 5. 2 is a coefficient. So you are literally going to do 2 to the 5th. Are y'all okay with that?
Yeah.
I haven't gotten to the x yet. I'm going left to right. So you're good. So the x was squared, but now I'm raising that to the 5th. So y'all, my rule says multiply. What is 2 times 5?
10.
Good. So that's x to the 10th. You see what we did? Okay. Move on. Move on to your y. There were 4 y's, but now I'm multiplying by 5. So how many are there?
20.
20. Good. Now this is where y'all usually mess up. I'm going to say it again. This is not 10. What does 2 to the 5th mean? Because before y'all even start talking, does everybody agree this is just a number?
Yeah.
We should be able to find what 2 to the 5th is. So what does 2 to the 5th mean?
Multiply 2 5 times.
Good. Multiply 2 by itself 5 times. So look, 1, 2, 3, 4, 5. You need to simplify this. Good. He's good at mental math. Good job. So look, 2 times 2 is 4. This 2 times 2 is 4. So what's 4 times 4, babies? 16. And then you got one more 2. So 16 times 2, he said, was
32.
32. And now it is simplified. Do we need another one? Do y'all want one to try?
Yeah.
They're saying they're okay if we move on. Do y'all want another one?
Elmer.
No, I'm good.
Well, who just left?
Come on.
We ain't done.
Yeah, the other Kamar.
It was my graham cracker. He better hop back in here. I'm so glad you told me that nickname. Are y'all okay with example 5? I'm hearing no for another one.
Yes, we're okay.
All right. Thank you, Kamari. Let's move right along. Rule number 4. We got 2 more. I told you this is the most notes we'll take, honestly, probably all year. So y'all just hang with me, though, because I want us to be able to have a practice day tomorrow. And they're not hard notes. It is a lot. Jordan's going to hate me, but he'll be all right. Jordan, you want to deal with negatives or zeros first?
Zeros.
Zeros. I like that. All right.
Zeros are easy.
Rule number 4, 0 powers. This one is my favorite. Oh, you do remember it.
Zeros are the easiest ones.
Yeah, they're my favorite, but kids miss this. And also, I don't think they showed you in middle school why it works, so I'm going to show you why. They might have if they did and you had a really good teacher. All right, a 0 power. Any term raised to an exponent of 0 so you did learn this last year. I asked y'all about these yesterday and y'all were like, I don't think we learned that. You didn't know there were this many rules? All right, any term raised to an exponent of 0, what do we get? Who remembers? I always hear that.
No, it's 1. It's 1. It's 1.
It is 1. Anything raised to the 0 is 1. I'm not sure that they showed y'all why, so I'm going to show y'all. We're going to do a little magic trick. I need you to hit the lights for me, bro. Oh, I love showing you where stuff comes from. Because I don't like y'all memorizing crap. Because if you memorize something, you don't remember it the next year. Here we go. Y'all can see me now. Nice and bright. You ready? All right. Everybody watch.
Watching.
How many markers do I have?
1.
I have 1 marker, right?
Yes.
So does everybody agree this is like m to the 1 because y'all can see my 1 marker?
Mm-hmm.
Okay. How many markers I got?
2.
So it's like m squared. Kershawn, you see this, right, babe? Yeah. You can see it? All right. How many markers do I have?
0.
Are you sure?
You have 1.
Oh, so they said you still have them. You just put them down and they can't see them now. I got a whole bunch, in case you were wondering. That's how I got all these colors, okay? I have a whole bunch of markers. You just can't see them. So think about it this way. This is how I would do it if y'all were in person. You can see the marker I have, correct? Now, does everybody agree? You can see my marker 0 times. Kershawn, you watching? You can see my marker 0 times. Does that mean I don't have a marker?
No.
There's still a marker there. So because there's still a marker, even though we can't see it, we need a placeholder. And y'all know in math, whenever we use a placeholder, we use a 1. So anything raised to 0 just equals 1. Let me show you another example. You can hit my lights, babe. We don't need them anymore. These are Z's, not 2's, before y'all say they're 2's, although it wouldn't really matter. They always try, you know, Shania, they try to play my handwriting. Yes, they're Z's. They're Z's. If I put a line through them, they're Z's. All right. Z to the 4th over Z to the 4th. We are dividing. What do we do with our exponents when we divide? Subtract them. So y'all, what's 4 minus 4?
0.
It would be 0. But we just learned anything to the 0 is
1.
1, and here's why. Look at me, Kershawn, because this is what you just asked about.
If you do 4 divided by 4, they equals 1.
Right. If you have anything divided by itself, it cancels, right? So that makes it a placeholder of 1. Y'all with me? Yeah. All right, let's do an example. Some of y'all like, we done just did one. That's one right there. I got 2 for you on this because y'all be missing this sometimes. We are almost done, so y'all hang with me. Y'all have done great today. You're welcome. All right, what do we notice?
That there's a 0.
That there's a 0 where? Because that's important. Where is it at?
Outside.
On the outside. So y'all look at this. Everything on the inside is going to get that 0 because we would distribute it in, right?
Mm-hmm.
So we just wrote down any term raised to 0 is what?
Yeah.
If all of these are raised to 0,
1.
it's just going to equal 1. No matter what the equation is, whatever is raised to 0, that part is 1. This one just happened to be the entire thing raised to 0. Very good. That's my next example. You read in my mind. Good job. So let's do another one. So he asked, in case you couldn't hear him, you're going to get extra credit because that was a good question. He asked, what do you do if there's a 0 inside the parentheses? So let's look at it like this. Ready? All right. Which term, because this says any term, which term has the 0? Good. Not the 2, just the x. Good. So look at this, y'all. This x to the 0 is really just a 1, right?
Mm-hmm.
Okay, so let me ask y'all a question. What is 2 times 1? Because those we're touching. What's 2 times 1?
2.
2. So do we really need the 1? No. Now you can put it by all means. You can put 2 times 1, and I'm going to bring everything else down. But y'all just told me 2 times 1 is 2. So now how would I simplify what's left? Nope.
Distribute.
Yes, good. Distribute. Take that 2 into everything on the inside. So what am I left with?
4 by 2, 6.
So 2 squared. Don't simplify it yet because some people are going to say it's 2 times 2, and that's not why. This is 2 squared y to the what?
6.
I think somebody said it. What's 3 times 2? Why y'all quiet? What's 3 times 2? Quit singing. Pay attention. What is 2 squared?
4.
I would love, it's 4, baby. I would love if y'all could say that faster. Pay attention. 4. 2 squared is 4. I should be able to give you something squared and you should be able to spit it back out. What's 9 squared? Good. What's 3 squared?
32.
Yes. What's 6 squared? You should be able to tell me that. All right. Are y'all okay with how you would do it if the zero is on the inside? That part just becomes a 1. If 0 is on the outside, the whole thing becomes a 1 because the 0 would go into everything. Are you sure? All right. Are y'all okay with the zeros? All right. Last but not least. Jordan, I don't know if you're gonna like this one. But I'm gonna use you as my example. Remember, if you have a question for me, just unmute and ask it, or you can pop it in my chat box.
Pop it in her chat box.
In my chat box. Welcome to my chat room. Y'all are too young to know what chat rooms are.
Y'all used to do that on a computer back in the day. So
Back in the day, you were probably like 2 when you were doing that. Because those were a thing when I was in middle school and high school. Chat rooms. I need my pen. I threw it at you. That's fine. I'll use a pencil.
Let me ask my mama what the
You
chat
didn't have to
room
throw it
is.
like that. I played sports. I can catch. All right. Negative powers. Jordan, can I use you as an example?
Yeah.
It's not a bad thing. Did you say no?
Say yeah.
Okay. All right. If I tell Jordan, I hope we're all listening. If I tell Jordan to go run around the track 2 times, can he do it? Yeah. If I go tell Jordan to run around the track 8 times, can he do it? Well, he might be tired. He might start walking, but he could do it, right? Yeah. Jordan, if I tell you to go run around the track at school -5 times, what does that mean?
Don't run around it, right?
Right. It don't mean run backwards. If I tell him to go do it negative times, he's going to look at me like, what the HE double hockey stick this lady talking about? Right? All right, Cam, if your mama says, Cam, go clean your room, and you need to go ahead and clean it 2 times because it's that messy. Or maybe after basketball practice, she said, you need to go shower twice because you stinky. All right? What if his mama said, go shower -4 times? What does that mean? We don't know what that means. Negative exponents, negative time. We don't know what that means. Does everybody understand that? So look, you can't have negative exponents. I'm hoping you learned that in middle school, but I've learned over the years that you don't always learn this one in middle school. This is usually the one that's brand new. You cannot have negative exponents. Okay, you learned this. What you do if it's negative? Yes, you do. Yes, you do. If you have a negative exponent, it can't be there because we don't know what that means. So you're going to have to flip it to make it positive. This is the part that's different. It is. You will have to flip the base with the negative exponent. You will have to flip the base with the negative exponent to make it positive. This is the one that y'all usually don't quite understand, so I will definitely do 2 examples, okay? Me? Yes, that was very random. You can't have negative exponents. If you have one, you'll have to flip it to make it positive. So write this example down for me. All right, y'all ready? Can I have b to the negative fourth?
No.
No, so watch what you do. You're just gonna rewrite it so it's not negative anymore. So does everybody agree this is the part that's negative, the b to the negative fourth?
Yeah.
Okay, I'm going to flip it and put it in the top now. And when I flip it to the top, it is no longer negative. It's the opposite of negative, which is positive. So this is kind of like when we did perpendicular lines. I'm gonna bring that b up to the top, and now the 4 is positive. Now, what would be understood underneath this? Good. Do you have to put it over 1? Huh? No, why not? What?
You know what I mean, right?
What's 4 divided by 1?
4.
What's 5 divided by 1? So I think what you meant to say is anything divided by 1, you get what you started with. You got to be able to explain stuff to people. Let's try another one. If y'all have a question, unmute and ask me. Make that a 2. Sorry if that messed you up. And make that negative. I'm thinking outside the box.
I think
All right, babies, what am I doing? Yeah, a lot, sure. What are we doing? What operation? Multiplying. Don't laugh at him. You can make him think he's funny. Multiplying. So my numbers, my coefficients, I'm going to multiply. What is 2 times negative 4? Negative 8. There we go. Now, since I'm multiplying, what do I do with my exponents?
you add them.
Oh, yes, you add them. So I got m to the 4th, m to the negative 6. Some of y'all struggle with this, so this is why I threw this one in here. What is 4 plus negative 6? Negative 2. M to the negative 2nd.
You make that negative a bottom.
Okay, good. Let's talk about it. This ain't your answer. Because if I said I have markers negative 2 times, nobody knows what that means. So I can't have a negative exponent. So listen to what I just said, because this is where y'all mess up. Is the 8 an exponent? Then it's allowed to be negative. It's not an exponent. It can be negative. We know what negative numbers are. We don't know what negative exponents are. So do y'all agree this is the part that I have to move?
Yeah.
Okay, what is it over right now?
1.
Yeah. What is this term over right now? Understood what?
1.
Good. Think back to when we did slope. It's over and understood 1. I got to move the exponent in its base. That's negative. The 8 does not move. That's not an exponent or a base. That's a coefficient. We're going to move it down here. And once we move it, we can do the opposite. So what will it say now? Somebody tell me what's left.
1 over negative m over 2.
Be careful. Not 1 over. What's in the top? What kind of 8? Negative 8 is in the top. You don't move it. It's not an exponent. Now, what's in the bottom? M to the what? Not negative anymore. We moved it. Positive 2. There we go. That's it. If it's negative, you move it. Now, not the numbers, not the coefficients, the exponents.